Okay, example 9. Let me see whether example 9 is there. Example. Okay, sorry. Example 9 is the one that we want to talk about. Sorry. Example 9 is the one we want to talk about. What if this point is a stationary point? Can? Okay. Oh, look up. Look up, look up, look up. Now, can I have attention, please? Okay, let's do example 9, okay? Not much copying. Not much copying. Look up. On separate diagrams, you are to sketch y equals to this. Now, this is part of curve sketching. This is skill of chapter 10. So, tested in mid-year, right? So, better know. Okay, do we know how to sketch this? Can, of course, no problem. Okay, you can either use your GC. Yes, we can use your GC, no problem. Or if you want, if there's, in this case, we do it by hand, but actually you can use your GC. Follow? So, you can find what are the stationary point. Okay, dy dx, I differentiate. Yes, I differentiate. I should be able to get 2 stationary points. Don't care how we do it, we do it. Can? Okay. Now, and again, we don't care how we all do it because this is a simple cubic. You can use your GC. The comments in red you ignore for the time being, okay? Don't copy the comments in red first, okay? It is, you just sketch the blue because this is a simple cubic curve. It should cut 0, 0. It should cut 1, 0. It should have a maximum point here, and it's just simple cubic. No problem. Okay, don't copy the red comments first. Okay, don't copy that first. Do we all recall the reason why if I take square root of this point will give us a vertical tangent loop? Do you all recall? Or don't recall? Don't recall? Hello? Recall or don't recall? Okay, if you don't recall why this gives us a vertical tangent loop, can you shake your head? It's all recall. No. Okay, how to explain? Yeah, how to explain? Recall or don't recall? Don't recall. Okay, never mind, we go through. Never mind, it's okay, it's okay. Never mind, it's alright. Never mind. We can do it all over again, never mind. I'm trying to explain one more time, okay? Remember this, right? dy dx at x equals to -2, dy dx is f prime -2. Correct? The gradient at this point is f prime -2, which we assume to be some value a. That means not 0. Now, we want to explain why the gradient here is vertical. Correct? Vertical tangent. So we are saying, okay, dy dx, we are able to use chain rule and say this. Correct? And then you have a f prime x. Correct? Chain rule tells me that. No problem. Yes, which is actually equals to f prime x over 2 square root fx. Correct? Okay? Now, at this x-intercept, x equals to 2, what is the gradient here? We say it is, the gradient is f prime -2 over 2 square root f -2. Now, we all know that at x equals to -2, y f is -2 is 0. So, denominator is 0. Correct? Then we all said that, okay, if this has a gradient of a, which is not 0, I get a divided by 0, I will get undefined, I will get a vertical tangent. Do we all remember? Okay, now ring a bell, right? Now we're going to deal. So now let's go back to the question. Here, clearly, the gradient here is not 0. So obviously, there is a vertical tangent loop. Now the problem lies in this point 1, 0. Because at 1, 0, at x equals to 1, your f prime 1 is 0. Then you get 0 divided by 0, which is indeterminate. You have absolutely no idea whether 0 divided by 0 is 0, undefined, or 2. You can take on any value. Do you follow what I'm saying? Okay, 0 divided by 0, if you don't know by now, is an indeterminate form. Cannot, don't know. So how are we going to do this? Okay, to cut the long story short, it's actually not difficult. I'm not going to do it analytically. Use GC. Okay, to cut the long story short, use GC. But how to use GC is a skill as well. Okay, how to use GC is a skill as well. So let's go through how to use GC. Now, we actually want to find out, let's scroll up a little bit more. This is your y equals to fx. You want to find out y equals to square root fx. What is the gradient near 1? Follow? So I use my GC to tell me this. Okay, let's do this together. Okay, let's do this together. Let me do this. Scroll it down here. Okay. Oops. On. Turn it on. Okay. Okay. Now, let's look here. This is your fx. I want to square root fx. I want to find out what is the value of the gradient at this point, near to this point, 1.001. Okay? What is the gradient? So, let's do this. Follow, follow, or follow. Okay. Alpha window. To bring this menu up, and then press 3. This function, I'm sure you have seen before. Okay, then you differentiate. Differentiate means actually find the value of the gradient, right? Where take square root. Correct? Just now we already defined y1, right? If you have not defined y1, then you cannot do it. Okay? Okay. Let me check whether my y1, correct, it's the correct y1. Okay? It's the same y1, Okay? Make sure you have the same y1. Y1 is this. Y1, if you define y1 as this, then you can do it. If you have not, then cannot. Then you got to type this in. Then you laugh at your friend. Thank you. At x equals to 1.001. Make sure it's not 1. Because when you type 1, the calculator will try and take the 0 divided by 0. The calculator cannot handle. Is my y1 correct? Oh, yeah, my y1 wrong. No wonder. So never mind. I have to laugh at myself. Good. Can. What does it give us? 1. So that means what? That means at a value that is very close to 1, 0, the gradient is 1. It's not 0. It's not undefined. Undefined will give you a vertical. That means if you see a very big value here, then you know it's a vertical tangent loop. But you see a 1, that means this, for the deduced graph for here, at this point when you take square root, the gradient is 1. Let's do the other side, okay? in case, okay, now, do you all know you go up, up, enter? Cannot. You all know this, right? Up, up, enter. Then I type 0.999. What do I get? Negative. Because it makes sense, It makes sense. Correct? All we are saying is when we take square root here, that means at this point when we take square root, the gradient is -1. Here is +1. Correct? So now we can sketch. Possible. Okay, so when we sketch this, the thing to note is at this point is a vertical tangent loop. However, at this point, it is what we call an X shape. What we call an X shape because at this point the gradient is 1, and over here the gradient is -1. Do you follow what I'm saying? Can? So be very, very careful here. Those maximum minimum point is quite easy, you can deduce on your own. Okay? But what I want to focus on is this skill. To use the GC to help us find the gradient whereby the original graph had a stationary point. Okay, maybe we can pause here for a moment, just 1 minute. You can talk to your friend to discuss about this, okay? Let the idea sink in a little. Okay? Let the idea sink in a little.